All right, today we're going to talk about proportions, similar polygons, and scale factor. So as a reminder, a proportion is an equation written as two fractions with equal ratios. For example, you have A over B is equal to C over D. All right, so when you are solving for proportions, you want to cross multiply. And then as I showed you here, A D times A or A times D equals B times C. All right, so to solve each proportion, we're going to use cross multiplication. So for this first one, just exactly what I did here, I go 6x, and then I'm going to go 9 times 20, which is 180. So either way, you could have written it this way also. It's fine. And then divide both sides by 6, and x equals 30. So that's all you do with that one. You still do the same process if you have anything that is like this, x plus 3. What I suggest to do is put parentheses, and the reason why you want to put parentheses is because when you multiply this way, it's actually 5 times all of whatever the numerator is. So in this case, it's 5x plus 3 with your parentheses, and then you would distribute to each term within the parentheses. So you'd get 5x plus 15. And then we said 4 times 2 is 8. And then bring that down. Subtract 15. And then once you subtract 15, you get negative 7 equals 5x. Divide both sides by 5. And you are going to get a fraction here, but that's okay. That simplifies to 1. So you're going to get x equals negative 7 over 5. And that's your answer. So you can still do this, just remember to put parentheses around whatever the term or the numerator or denominator is. All right, so you can have similar polygons. Two polygons are similar if and only if their corresponding angles are congruent. So they have to have corresponding angles, same measure. And their side lengths are proportional, very important. The symbol is, it looks like a little wavy line. That symbol means similar. All right, so let's go ahead and let's look at some examples here. And as you can see, I color-coded everything for you. So look at the information that you were provided. The angle marks tell you A is congruent to D. It tells you angle B is congruent to E. And then angle C is congruent to F. So that's the information provided. So therefore, we know the corresponding angles are congruent. So now what we're going to do, we're going to show that the sides are proportional. And when you show that the sides are proportional, you have to take the corresponding sides and set up your ratio. So for this one, we have AB, because angles A and B are congruent, so we know that D and E is the corresponding side to that. Or excuse me, A and D are congruent and B and E are congruent. So 10 corresponds with 20. So that's why we set up those two sides, because they correspond with each other. And then this simplifies to 1/2. So your highlighted side has a ratio of 1/2. All right, so that side's there. Let's go to the next one. We have BC. So since angle B is congruent with E and angle C is congruent with F, we know BC corresponds with EF, and that's what we did right here. And we're going to take those sides, and BC is 6, EF is 12. So when you simplify that, you're going to also get 1/2. So far we have the same proportion, and then let's look at the last part. So we have CA, angle C corresponds with angle F, and angle A corresponds with D, so therefore we know that CA and FD correspond with each other, and here you can see I've got their measurements here. And then now we're going to go ahead and we're going to simplify that, which is also 1/2. So everything has the same rate or the same factor, scale factor. So therefore the corresponding sides are proportional since they're all 1/2. And now you can write this, triangles are similar, and you, again, order matters. So remember, order matters. So you know which sides correspond. All right, so here you would put triangle ABC is similar to triangle DEF. And we know that because sides are proportional, angles are congruent. All right, on this next one, it's an example. I'll start it for you. You're going to finish. So again, it says ABC is similar to DEF. So A goes with D. B goes with E. And C goes with F. So knowing this, which you should have written here. So knowing this, we can start to set up corresponding sides to see if they're proportional. So since AB, the corresponding side, is going to be DE, and then you're going to go ahead and finish this, and then BC is right here, and that corresponds with EF, and then you have CA, which corresponds to FD. So you're going to finish this part to determine if it's proportional or not. All right, so now we need to figure out if the sides are similar. So remember, if sides are similar, the corresponding angles are congruent, but the sides are proportional. So let's find this out. So I have angles. So A goes with D. C goes with F. B goes with E. And this is what we're going to figure out if it is corresponding sides are proportional. All right, so let's go ahead, let's get started. So AC and is 10, DF is 15. So if you're to do this correctly, then you know that this would equal 2/3. Okay, so far so good. So everything has to equal 2/3 in order for it to be proportional. All right, so now we're going to do CB. Oops, let me highlight that. So now we're going to do CB, which is 8. And we know that FE is 12. So again, if you're to simplify that, you'll also get 2/3. Okay, so far so good. And then now let's check the third side because all the sides need to be proportional. So here you're going to have 12 over 18, which is also going to be 2/3. So since everything has the same, this is proportional. So what you would do is you would say yes, and then you're going to put triangle ABC is similar to triangle DEF. And that's your answer. All right, so you're going to try this one. And hint, all angles are congruent because they are rectangles. So I already drew those in there for you. And then you're going to check to see which sides correspond with each other. So go ahead, try that one. And then now let's talk about scale factor. Now scale factor is figuring out what number you're multiplying by to see if they're proportional or not. So if you can't tell which side is the pre-image, assume the figure on the left. So this guy would be the pre-image, and then it goes that way from there, or it could be top to bottom. So pre-image is your starting figure. So that's before you have any, you multiply it by the scale factor. And the image is the after. So I like to remember it as new over original, but your new is your image and your original is your pre-image. So very important, it says each pair of polygons is similar, determine the scale factor. So you're basically finding what proportion are you multiplying it by to figure out if it's proportional. So it's very important you use corresponding sides and angles. So let's get started with this one. Now this is the first one, this will be the pre-image, and this one is the new. So that's the image. All right, I want you to determine the scale factor and solve for x. Well, the new is your image, the original is your pre-image. So let's look here, find a corresponding side. So here's your original, and here's so this is your pre-image and this is your image. This is this guy. So you're gonna set that up as a fraction. So in this case, if you were to have 6 halves, you're gonna have a scale factor of 1/2. So your scale factor is 1/2. Well, that makes sense because if you're to have a reduction is a scale factor less than 1. So this means the shape is getting smaller. Which makes sense. All right, so now that we did that, now we need to actually solve for x. So again, you're going to take your corresponding sides and you're going to have 1/2, which is your scale factor, and we're going to solve for x. So again, 1/2, which was your scale factor, and then you're going to go x over 13, so you're going to figure out, x over 13 to figure out x and 13. All right, and you're going to cross multiply. And you'll get 2x equals 13. Divide both sides by 2. X equals 6.5 or 13 halves. So x is that. All right. So now I helped you do this one, and I'll get you started with it. So first you have to find x. So you have to figure out, and these are kind of rotated and then one's enlarged, so it looks like it's getting bigger. If its scale factor is greater than 1. So let's see what's happening, because right now it definitely looks like it's getting bigger, so our scale factor should be greater than 1. But first let's solve for x. So find your corresponding sides. So I've got 10, and the corresponding side there would be x over 2, so that's what I did here. And then we're going to take 8, and we're going to put that over x minus 1, which is what I did here. So now when you cross multiply, remember that x plus 2 needs to be in parentheses so you can distribute. And then here, again, remember this is in parentheses when you cross multiply. So as you're doing that, you're going to solve for x. Once you solve for x, then you can find the scale factor. So go ahead, finish that problem. All right. Now here is you just have to find the length of each side. Well, it's actually pretty easy. You just take the original side and multiply it by the scale factor, which happens to be 1/2. So once you're doing that, 6 times 1/2 is going to be 3. A way to set it up, though, is to set up a proportion of the sides. So you're going to have this side corresponds with this side. So this is your new over original. So that's where I got xy over 6. And then it said the scale factor is 1/2. So now we're going to equal this. So we're setting up your proportion. And now we're going to go ahead and cross multiply. Divide by 2. Xy equals 3. So we know that xy is actually equal to 3. So you're going to go ahead and you're going to set up the other ones. So you're going to take 1/2 equals yz. And we said that's over 8. Cross multiply. So you're going to get 2yz equals 8. Divide by 2. So if you notice, you're dividing everything by 2. And then here, you go 1/2 equals xz. So I did the long way. The easy way is just to multiply everything by 2, or by 1/2, excuse me. You would have gotten 5 is xz. So there you go. And then so your 3 sides are 3, 4, and 5. Bam, that's it. So just remember, scale factor is new over original. If it is less than 1, it's a reduction. If it's greater than 1, it's an enlargement. And everything should be proportional if it is similar.